For number 5, the question is, will water or carbon tetrachloride dissolve each of the substances? Now, soluble and miscible mean the same thing. For soluble, it's usually talking about whether a solid will dissolve, and miscible means will a liquid dissolve in another liquid, like alcohol and water. Water is a polar solvent because it's H2O. Carbon tetrachloride is a non-polar solvent because it is symmetrical molecule. So with each of these, the rule we want to keep in mind is that like dissolves like. So polar things dissolve in polar solvents, and non-polar things dissolve in non-polar solvents. So ionic counts as polar because the sodium is a full positive charge, fluoride is a full negative charge. So there's a big difference in positive negative, even more so than water. So ionic compounds dissolve well in water. So very polar or ionic is going to dissolve in polar water. So for sodium fluoride, our answer is water. For PF5, this one's tough because it's a molecule that we didn't have to talk about, but those 5 fluorines spread equally around phosphorus is actually going to end up being a non-polar molecule. So it's going to dissolve in the non-polar solvent, carbon tetrafluoride. Argon only has London dispersion forces. It's not even a molecule, so it can't have a dipole. So argon is definitely nonpolar. It will dissolve in carbon tetrachloride, the nonpolar solvent. NH3 can hydrogen bond, so it's very polar. So a polar molecule is going to dissolve in the polar solvent, so it'll dissolve in water. Ammonia in water is in a lot of your cleansers like 409 or Windex. CH3F, if you draw it, is also polar. It's got one very electronegative atom on one side, that's fluorine. Polar molecule is going to dissolve in the polar solvent, water. And methanol has hydrogen bonding as well. The OH bond makes this very polar. Because it has hydrogen bonding, water has hydrogen bonding, they're very much alike. So this guy will dissolve in water. I hope that helps.